66 million years ago, a rock roughly the size of a city traveled toward Earth at 40,000 miles per hour. Now, imagine a slight gravitational nudge in the outer solar system alters its path by a fraction of a degree. The sky over the Yucatan Peninsula remains clear. The planet does not burn. We often tell ourselves a comforting story about the sequence of life on Earth. The traditional narrative assumes that mammals were an inevitable evolutionary upgrade, destined to replace the large reptiles as the rightful rulers of the planet. The fossil record paints a different picture. By the late Cretaceous, mammals had already existed alongside dinosaurs for over 100 million years. They were sidelined. They survived in the margins as small, nocturnal insectivores, hiding in the dark to avoid apex predators. The asteroid impact functioned as a mechanical prerequisite for the development of human life. In a world where these dominant food chains remain intact, the physical and ecological space required for primate evolution disappears. To understand this biological constraint, look at the ancestral Cretaceous mammal. It weighed about as much as a chocolate bar. It was twitchy, small, and heavily suppressed by its environment. This animated diagram illustrates a biological mechanism called ecological release. In any stable environment, dominant animals occupy the most resource-rich niches. Their presence applies continuous pressure that traps smaller creatures at the bottom of the food chain, preventing them from evolving into larger forms. When a mass extinction removes those apex predators, that pressure disappears. The surviving bottom dwellers experience an explosive evolutionary radiation, rapidly mutating to claim the newly opened territory. We can trace the exact geographic trigger for our own ecological release to a specific scar buried off the coast of Mexico, the Chicxulub crater. If the asteroid misses, that environmental pressure never lifts. The explosive diversification of early mammals does not happen. The pathway that eventually leads to the primate lineage remains obstructed by animals that already perfected the art of dominance. The human family tree remains suppressed by a biological ceiling that required a planetary catastrophe to remove. The Earth itself, however, would not have waited for the dinosaurs. Tectonic plates continued to drift, eventually forcing India to collide with Asia and pushing the Himalayas into the sky. This geological activity triggered a slow global cooling trend. The dense tropical jungles of the Mesozoic gave way to a new type of vegetation, leading to a massive expansion of open grasslands across the planet. Surviving dinosaur lineages would be forced to adapt to these cooler, exposed biomes over tens of millions of years, moving far beyond their recognizable Cretaceous forms. Tyrannosaurs migrating into freezing high-latitude forests would evolve dense, insulating coats of feathers to regulate their body temperature. Out on the new open plains, massive, long-necked sauropods would form complex herds, utilizing deep infrasound to communicate across vast distances. 66 million years of adaptation creates a divergent reality, a world of alien landscapes and biological structures that follow a logic entirely separate from our own, which raises the ultimate evolutionary question. Without primates, would any species in this alternate timeline eventually look up at the night sky and wonder about the stars? We don't need to rely on science fiction tropes of upright reptiles to find the answer.
We only need to look at the lineage of highly active theropod dinosaurs that actually survived the intact: birds. Modern avian intelligence provides direct evidence of what dinosaur cognition can achieve. Crows demonstrate complex problem-solving, episodic memory, and the ability to manufacture specific tools from wire and twigs. Species like the African gray parrot have proven capable of identifying colors, accurately categorizing materials, and grasping abstract mathematical concepts, including the number 0. These creatures evolved these abilities while restricted to the sky and competing with mammals. Now, project those cognitive traits into an alternate timeline. Give a large-brained theropod 66 million years of unconstrained evolution, free from mammalian competition. Earth would likely have produced an advanced intelligence, but it would operate on a neurological framework analyzing the universe through a lens outside our understanding. This forces us to confront the Fermi paradox. The universe is incredibly old and impossibly vast, heavily favoring the probability of life. Yet, when we listen to the stars, we hear absolute silence. Astrobiologists hypothesize that the galaxy might be full of Earth-like planets that never experienced an extinction event perfectly timed to force a change in the dominant species. They are permanently stuck in their own Mesozoic eras. These planets could be teeming with rich biology, but a thriving ecosystem doesn't automatically build a radio telescope. Without an ecological reset, those worlds never produce a technological observer capable of looking outward. Intelligence capable of reaching space is not a default result of evolution. We are a statistical anomaly, born from the timing of a planetary catastrophe. We exist biologically because something terrible happened to something wonderful. We are the only animals capable of digging into the earth, reassembling the bones of our predecessors, and understanding the exact mechanism that destroyed them. The dinosaurs had no way to detect the threat approaching them in the dark, and no capacity to act even if they had. In the year 2022, NASA's DART mission successfully slammed a spacecraft into an asteroid, measurably altering its orbital path. We are the first organisms to intentionally change the trajectory of a celestial body. We are the children of the asteroid's legacy. But because we can look up and calculate the math of the solar system, we are the only species with the power to ensure we are never at its mercy again.